Hi everyone. Today I just want to solve this problem, which is for Mohr circle. Find the first. He asked me to find the stresses, the principal stress. So the principal stress, I can find it if we have sigma x and sigma y, and also the shear. So we have 2 points. I'm gonna show you. We have point A here. The point A sigma x, which is 100 MPa. This is tension, so it's gonna be positive. The second yx, so the coordinate, which is for the shear, 48. 48 is rotating like this, so it's gonna be negative, clockwise negative. So 48 negative. For point B here, we have 60. For the normal stress is 60 up, which is tension, and also we have the shear like this, rotate like this, so it's going to be positive 48. So what you need to do, just draw these 2 points. So I'm going to draw these 2 points here. Okay, so the first point we have, maybe I'm going to draw it like this by using the roller. So y-axis, and we have x-axis. Okay, so we have the first point, 100 negative 48. So 100, let's say this 100, and down is 48, sorry, up 48. Why? Because we know that this one is sigma and this one is tau. So for the sigma, positive is going to be in the right and negative on the left. So for point A, which is 148 and 48, say here, say this is point A. You can use it by using roller, or also you can by doing a scale. So this is point A, which is 148. Okay, and we have point B. Point B is 60 48. So 60 also positive. So we have 1 2 3 48 somewhere here. So this is point B. So the 2 points A and B, we're gonna draw a line between B. So this is B, which is 60 48. Okay, B 60 48. Now what I need to do, I'm gonna find the center. So of course the center is gonna be this one. This, the point is the C, the center. So I'm gonna draw a circle by put my pin here, and then draw a circle. So I'm gonna draw a circle. So circle, gonna put it like this. It's like this circle. I think this is perfect. Okay, this circle, which is for B, I'm gonna just put B here, which is 60 48, and this point A. Okay, so the first thing we need to find is the principal stresses. Okay, how can we find the principal stress? The principal stress is just the principal stress is this one, this point and this point. Okay, so how can we get sigma maximum, and this is sigma minimum? Okay, first of all, we can find if we have this one is 40 8. Okay, we can find the center, this distance, which is equal to this distance. How much these two distances? So okay, so we have a from here to there is 100. This is 100. Okay, and from here to there is how much? 60. So if I said 100 from this point to this minus from this point to this, I will get all this line divided by 2. I'm gonna get these two parts. Okay, so 100 minus 60 divided by 2, which is gonna be 20. This is 20 and this is 20. Okay, so the first thing I got 20 from both sides. Okay, the second thing I need to find R, this R. Okay, you see this triangle, this R, I need to find it. If you have this 20 and we have this line is how much? 48. So we have triangle like this. I'm gonna put it like this. I need R. We have this up is 48 and this we have 20. So that means R is gonna be square root to 20 square plus 48 square. This answer is gonna be 52 MPa. Okay, so I got R 52. I'm gonna put it here. R, I got it 52 MPa. Okay, now how much sigma x and sigma minimum? So sigma maximum is gonna be R, which is all this R plus this distance, correct? That is gonna be sigma maximum. So R, I have it. How much this distance from center to this? How much? Correct? How much this one? This one is the average. It's called sigma average. Why? Because we have sigma 100 from this point to there. We have 60. So of course the average between them is going to be 100 plus 60 divided by 2. That one give me 80. Okay? So 80, I'm going to put it 80 here. So 80 is going to be from the center to this. It is 80. Why 80? As I said, it is the average. Which average? Average between 100, this 100, and also between the 60, this 60. So average of 160 is going to be 80. Okay, so sigma maximum, it will be easy. I can find it, which is how much? R, this R, plus this distance, which is how much? 80. Sigma maximum is going to be equal, how much R? R is 52 plus 80 is going to be 135. Sorry, 132 MPa. This sigma maximum. What about sigma minimum? Sigma minimum, this location is sigma minimum, which is how much sigma minimum? You see, we have this distance 80. Okay, this distance, which is 80, minus R. So sigma minimum is going to be 80 minus 52. Okay, so 80 minus 52, 28 MPa. So again, sigma maximum is R, this R, plus this distance. Maybe I'll put it in the red. This R and plus this distance is going to be sigma maximum. What about sigma minimum? Sigma minimum is R, this distance, all of it, minus R. That will be sigma minimum. So sigma maximum and sigma minimum, we found it, which is the principle. The second one, the second request, I'm going to show you what he needs. The second one, just drop this one. second, which is part B, you need the stresses component exerted on the element obtained by rotating the given element counterclockwise through 30. So he said, this element, you have it. I need how much the stress is. If we rotate AB, I'm going to rotate AB. How much? I'm going to rotate it AB by 30 degree clockwise. What's that mean clockwise? That means this one, this direction. So I'm going to rotate this direction to the clockwise by 60. Why 60? He said 30. I'm going to say times 2 is going to be 60. So I'm going to draw another line here. Let's say green line. By rotate this, how much rotated? Rotated 30 times 2, which is 60 degree. This line, the red, the green one, I need how much? This point, let's say AB, this is point C, A, B, C, D, E. Okay, so I need how much D and how much E. Okay, so which is easy, not that hard. Why? Because first of all, this is the tau, correct? For the D, for the E, this is the tau, which is the same. And then this is the sigma D, okay? And for the E is gonna be, this is sigma E. Okay, so if we have this angle, we need to find this angle. Do you remember? We got this side, we have this one is 48, and the R is 52. We can find this theta, correct? This theta, which is called 2 theta. Let's find 2 theta. So tan 2 theta is going to be, even sine, not the tan. Let's see how much we got it. Okay. And we have this side is 20, as we know. So tan 2 theta is going to 48 divided by 20, and the angle is 67.4 degree. Okay, so we have this one is 67.4 degree. We have this 60. How much this? How much this one? This one is going to be 180. Let's go alpha. So alpha equal to 180 minus 67.4 minus 60. So alpha is going to be equal to 52.6. Okay, I need this direction. How much this direction? Can find it by, we have R, this R, we have it, which is 52, and we have this angle. I can find it by using sine theta. So sorry, sine alpha is gonna be this. Let's call this direction called tau d. So tau d divided by 52. So from here, tau d is going to be equal to 41.23. Tau d 41.34. Oh, sorry, just a 3 MPa. Okay. And you know tau d is the same as the tau e, and tau e is going to be 41.3 MPa. Okay, which one is tau e? This one, tau e. What else I need to find? I need to find sigma d and sigma e. Okay, let's delete this one. Okay, sigma d, how much? Is going to be equal to, it's going to be this, all this distance minus this distance, correct? I can find this distance, let's say x. I can find it by cosine theta. cosine alpha. So x equal to, or cosine alpha is going to be x divided by the 52. So from here, x equal to 52 cosine alpha, and this x equal to a number. I don't know, I didn't find it now, but sigma d then is going to be a number. Then I'm going to say sigma d is going to be equal 80. Why 80? So from here to there, 80 from here to there, minus x. So 80 minus 52 cosine alpha, we have it is 52.6. So we got sigma d equal to 48.4 MPa. It's positive, so it's tension. What about sigma e? Sigma e is going to be 80 plus, okay, 52 cosine 52.6, and that will be give me 111.6 MPa. Okay, so we got these two things. So at the end, I'm gonna draw the element. So the element, we have it already is like this, then is rotated by 30 counterclockwise. So I'm gonna say, okay, the element that we have already like this, and was we have it, we have tension, the direction, and we have that one. Okay, then we rotate that one counterclockwise by 30 degree. We got another element. The element is like this. Okay, so the element, we have tension, and we have tension. The tension is 48.4, and this one is 111.6. And then we have shear. The first shear is 41.3, and the shear like this. You see this point, point D, point E, we have the tau is down, that means positive. Point D, the tau is up, that means negative. Okay, so here, so tau is clockwise is negative, and another tau is 100.6. Okay, so I'm gonna show you. So rotate this one by 60. They give me the first point D, and then second point E. Okay, so again, by rotated, give me the first point is, this is D, and this is point E. This is point D, and this is point D. Okay, and that's, that's the solution. Okay, thank you, bye.